हेलो बच्चों, आज हम डिफरेंशियल इक्वेशंस दैट इज ऑर्डिनरी डिफरेंशियल इक्वेशन डिस्कस करेंगे. वी विल डिस्कस लास्ट मिनट रिवीजन ऑफ ordinary differential equation. And this first type is linear differential equation and Bernoulli's differential equation. If dy by dx plus py equal to q, where p and q are functions of x, then the equation is known as linear differential equation. Or if we interchange these variables, then equation will be dx upon dy plus px equal to q. Now p and q are functions of y. Now for first equation, integrating factor will be e power integral p dx, and for second type, integrating factor will be integral e power p dy, because we have interchanged x and y here. Now the solution of this equation number 1 is, if dy by dx plus py equal to q is there, then y into integrating factor equal to integral integrating factor into q dx plus c. If we interchange the variables, then solution is obviously, in place of y there is x, in place of x there is y. Similarly, in Bernoulli's equation, suppose dy by dx plus py equal to qy power n, or if we interchange these variables, then its equation is dx upon dy plus px equal to qx power n. Now if first equation is given, then we will divide by y power n, this y power n, and equation reduces to this. We will put y 1 minus n equal to t and differentiate this. After differentiating, substitute these values in this equation. Or if dx upon dy plus px equal to qy x power n, then we will divide with x power n. Here x power n is here. We will divide with x power n. Again equation reduces to x minus n, dx upon dy plus px1 minus n equal to q. Here we will put x 1 minus n equal to t and differentiate like this and find the solution. Now if the given equation is exact, that is, when we said that given equation is exact, suppose mdx plus ndy equal to 0, where m and r functions of x and y. Now if we differentiate partially with respect to y and differentiate this with respect to x, and both values are equal, then the given equation is exact, and its solution is integral mdx taking y constant plus integral terms of n not containing x into dy equal to c. So integrate both these terms, this with respect to x, this with respect to y, and we will get the solution. Next is ordinary differential equation. If in the left hand side we'll get a function in terms of d into y, and right hand side is a function of x. Now CF is same for all the types, but for particular integral, CF means complementary function, particular integral is different. That is, first we will write particular integral equal to 1 upon f of t into fx. Now according to this value we will find the particular integral, or we can solve the particular integral. Now first type is, if function is e power ax, that is, suppose f of d into y is equal to e power ax is there. Now first we will write pi is equal to e power ax, because only exponential function is there, no other function is there. So here we will put d is equal to a, that is, d is equal to a. Suppose after substituting this value, we will get either a result, or we will get f of d equal to 0, that is, f of a equal to 0. Now this is known as case of failure. Now if case of failure is there, suppose when you find pi 1 upon f of a e power ax, and this f of a is equal to 0, then again go to this first step, that is 1 upon f of d into e power ax. First we will multiply with x. Find the derivative of this function, that is f dash d into e power ax. Multiply with x, find the derivative of denominator into e power x. Now again put d is equal to a. Now if we get answer, then it's okay. If again we will get f dash d equal to 0, that is f dash a equal to 0, then again we will get case of failure. Again we will multiply with another x, that is x square, second derivative e power ax. Again put d is equal to a and find the solution of particular integral. Now second type is, if in the right hand side there is either sin x or cos x, that is trigonometric function is there. Now suppose we have d square minus 1 into y equal to sin 2x. Particular integral is 1 upon d square minus 1 sin 2x. Now for sin ax or cos ax, we will put d square is equal to minus a square. It means here what we will put? We will put d square is equal to, this is our a, minus 2 square, that is minus 4. Now substitute this value, 1 upon minus 4 minus 1 sin 2x, minus 1 by 5 sin 2x. This is our particular integral. Same procedure for cos ax also. And also after substituting this value, here we get equal to 0, then this is a case of failure. Again we will simplify like this. First multiply with x, find the derivative, and here you will write now sin ax or cos ax, and again simplify according to this. Now third type is, if right hand side is equal to algebraic, that is x power m. Now m can be 1, 2, 3, 4 and so on. Now if right hand side is equal to x power m, then we will write first pi equal to 1 upon f of t into x power m. Suppose let our question is d square plus 4 into y equal to x square. Then pi is 1 upon d square plus 4 into x square. Now we will simplify this by binomial theorem. For that, take this constant common, d square by 4, shift into numerator, 1 by 4, 1 plus d square by 4 power minus 1 into, now apply binomial theorem, that is 1 plus x power n. Now here this is our x, this is our n. This is equal to 1 plus nx, n minus 1, 2 factorial x square and so on. Now apply this. Now up to which term we will simplify this? Check this power. If here is 2, we will simplify up to d square. If x power 3 is there, we will simplify up to d cube. Now 1 by 4, 1 plus n is minus 1. Compare these two values. X is d square by 4 plus n minus 1, 2 factorial x square. When we write this, x square means d square by 4 whole square, d square by 4 whole square. And when we differentiate x square, d square whole square means d power 4. When we differentiate x square 4 times, answer will be 0. Then no need to write this third term. We will write up to second term into x square. Now multiply inside, 1 by 4 x square minus d square by 4 x square. X square, double derivative of x square, 2. 2 by 4, 1 by 2. This is our answer. Now fourth is, if in the right hand side there is cos hyperbolic or sine hyperbolic function is there. Now for hyperbolic functions, cos hyperbolic is ex plus e minus x by 2 and sine hyperbolic x is e minus x minus by 2. First split this, e x by 2, e minus x by 2. Similarly this e x by 2. Now this is simple exponential type. That is first type. This is if right hand side is e power x. That is we'll put only d is equal to a here. Same if sine square cos square is there. Now first we will put trigonometrical formula. Sine square x is 1 minus cos 2x by 2 and cos square x is 1 plus cos 2x by 2. Split these two, 1 by 2 minus cos 2x by 2 or equal to 1 by 2 plus cos 2x by 2. Now 1 by 2 we will write here e power 0x, e power 0. Now in pi, here we will put d is equal to a. Now simplify second according to second type, that is d square equal to minus. Simple trigonometric, and this is simple exponential. Next is if product of two trigonometric function is there, that is one sine one cos or both sine or both cos, then we will apply product formula, that is 2 sine a cos b. Now according to this, now this is our a, this is our b. 2 sine a cos b is sine a plus b plus sine a minus b. Now for this 2 we will multiply and divide, so that we will get 2 sine a cos b, proper formula. Now apply this formula. Two sine a cos b is we'll get sine a plus b, 2 sine 10x cos 5x is equal to sine a plus b 15x plus sine a minus b 5x. Now in pi, 1 upon f of d sine 15x plus sine 5x. Now multiply this, 1 upon f of d sine 15x, 1 upon f of d sine 5x. In this first we'll put d square equal to minus 15 square. Now according to this, here a is 5, we'll put d square equal to minus 5 square. Next type is, seventh type is, if first function is exponential and second is v. Now possibilities for v is, we have discussed three functions: exponential, trigonometric, algebraic. Now if first is exponential, only two possibilities are there for v. Then v can be either sin ax cos ax or v can be x power n. Now if exponential function is there, what we will do, that is, suppose in the right hand side e power, let 3x cos 5x is there. Now what we will do, pi is equal to one upon f of d e power 3x cos 5x. Now shift this exponential in the left hand side, e power 3x, replace d with d plus a. Here a is 3, that is f of d plus 3 into cos 5x. Now the role of this exponential is finished. We will just multiply e power 3x. Now we have to simplify only this function. This is simple trigonometric. Now after replacing d with d plus a, now simplify according to this a. That is cos 5x is there. We will put d square minus 5 square. Now if suppose here algebraic function is there, suppose x square is there, that is suppose f of d into y equal to e power 3x into x square. Again we will write py equal to 1 upon f of d e power 3x, x square shift in the left hand side, e power 3x, replace d with d plus a. Now we will simplify this. This is simple algebraic x power m function. We will apply binomial theorem here. That is 1 plus x power n. Now next type is, this is our a e power ax into v type. Eighth is x into v. Now possibilities for v are again either exponential or sine cos. Now if exponential is there, then this is same type, e power ax into v. So it means for x into v, possibilities v is either sine ax or cos ax. Now next is a type is if in the right hand side f of d y is equal to x into sine ax or x into cos ax. Again for particular integral we will write 1 upon f of d x sine ax or x cos ax. Now this is x, this is our v. One of the formula is, that is you will write x 1 upon f of d into v plus d by dd of 1 upon f of d into. This is x, this is v. X as it is 1 upon f of d, v is here sine ax plus d by dd means derivative of 1 upon f of t into v. Now we have to simplify according to v here, and in the second factor first we will differentiate 1 upon f of t and again simplify according to v. Now v is either sine or cos, that is we have to put only d square equal to minus a square. Now next type is if this here power is 1, if power of this x is greater than 1, that is x power n means n is equal to 2 or greater than 2. Again possibilities of v are either sine ax or cos ax. That is possibilities of v are either sine ax or cos ax. Here n is 2 or greater than 2. Suppose n is equal to 2. That is f of d into y x square cos 5x. Now for particular integral 1 upon f of d x square cos 5x. Now here x power 2 is there and here is cos 5x. Now we know that cos x plus iota sin x is equal to e power iota x. If we replace x with 2x, then we will write e power iota 2x. If we replace 3x, then e power iota 3x and so on. This is known as cis form, in short, CIS angle. Now in this complex number, cos x is our real part and sin x is our imaginary part. Now in this question cos 5x is there. Now cos x plus iota sin x. In place of this I can write e power iota x. Similarly, in place of cos 5x, I can write cos 5x is the imaginary part of, cos 5x is the real part of, cos 5x is the real part of e power iota 5x, right? E power iota 5x is into iota plus cos 5x. This is a real part, this is our imaginary part. So for cos 5x, I can write this is the real part of e power iota 5x. So in this type of question, if sin x is there or sin 2x, 3x is there, we will write imaginary part. If cos is there, then we will write real part. Now suppose let the question is let d square plus 2 into y x square cos 3x. Now pi is 1 upon d square plus 2 x square cos 3x. Now cos 3x is the real part of e power iota 3x. So I will write this function as real part of 1 upon d square plus 2 x square e power iota 3x. Now if sin is there, then I will write imaginary part of 1 upon d square plus 2 into e power iota 3x. Now this is again which type? It's 7th, e power ax into v. V is either sin cos or x power n. Here v is e power ax into v is algebraic x power n. We will shift in the left hand side. It is real part of e power iota 3x. Replace d with d plus a. Now a is 3 iota, the coefficient of x, into x. Now simplify this factor. X power m is here, so we will apply binomial theorem, that is taking constant term or lowest power of d common, so that we will get 1 plus x power n in the denominator. And at the end, after simplifying, again split this function into cos 3x plus iota sin x and find the real part. Because in this question cos 3x is there, it means the real part of this factor is our answer. If sin is there, then imaginary part is our answer. And next is variation of parameters. Variation of parameter is actually applicable only for second order equation, that is highest derivative is second derivative. Let suppose a dy by dx, b y equal to, suppose right hand side is x. Now we will find first symbolic form, d square a d plus b into y equal to x. Now substitute this value equal to 0 and find the roots of t. Now according to roots, we will find the complementary function. Now because power is 2, then we will get only 2 values for d. It means for complementary function we will get c1 plus c2. Here we get functions of x. Suppose this is y1, this is our y2. Now to next we will find Wronskian. Which is equal to y1, y2, y1 dash, y2 dash. So y1, y2 is, y1 is coefficient of C1, y2 is coefficient of C2. Now find the determinant and find this is the value of W. Now particular integral is minus y1 integral y2 x w dx, y2 integral y1 x dx. Now this x is our right hand side in the given question. W will find from here y1 y2 coefficient of this C1 C2. Now simplify these two integrals, will find the particular integral, and at the end of every question we will write complete solution is equal to complementary function plus particular integral. This will be the complete solution of any differential equation. Now, thank you. Please share, like and subscribe me.